Now, after the impact, how do you determine this displacement? And that is the problem in kinematics. Remember, this is a constant angular acceleration problem. Or you can say it's a constant angular acceleration motion. And remember what we talk about in constant linear acceleration motion, or sometimes we just call it constant acceleration motion. You remember the formulation, right? S1 equals S0 plus V1 times T plus 1/2 of ACT times T squared. Remember? And this must be one of your old friends, right? We use this a lot in constant acceleration motion. How do we know it's constant acceleration? Because of this. In other words, if it's not constant acceleration, or if acceleration is not constant, this is not true. Now, all you have to do is just to convert this from the linear version to the angular motion. So we're going to say that S1, you replace with theta 1. This will be theta naught plus, how do you replace V with what? With omega. So this is going to be omega 1 T plus 1/2 of, you replace AC with what? With alpha C T squared. So up here, it is the angular, the linear motion for constant acceleration motion. And down below here is the angular version in constant acceleration motion. Now, this problem, of course, is easy to use because you define the original position to be 0. So to say that what theta naught is 0, there's no initial velocity, so V naught, V1 is 0. And all you have to do is to plug in the angular acceleration and use the time, then you can determine the displacement, angular displacement. Now, angular acceleration, we found it before, that's 5.62. So theta 1 is just 1/2 times 5.62 times 0.5 squared. And this will give you the value of 0.0351 radians. Now, what is 0.351? 0.0351 radians in degrees. So you would just use this relationship, 0.351 in radians. You multiply this by 180 divided by pi, and this will give you 2.01 degrees. So this is what we found. That means after 0.5 seconds, this bag is going to move for 0.0351 radians, or equivalently 2.01 degrees. So that's what it means. Right here, this is G before the motion, and after the motion is going to spin something like this. This angle right here is going to be 0.0351 radian, or 2.01 degrees. Now, because this angle is very small, so you can also calculate the displacement by just multiplying the distance times the angular displacement. Okay, so that will be the revisit for this problem. And I'll finish our discussion on Wednesday about the question on why this bag doesn't move. Well, the bag will move, the punch bag will move, but it takes time for the punch bag to move. At the instant, just like when you accelerate the car, at the moment you feel the reaction, but your car is still slow, right? So that explains principle of linear impulse and momentum, as well as principle of angular impulse and momentum. Any questions?